This is in the system shown below. MB is 4 kilograms, MA is 2 kilograms, as the pulleys are massless, and friction is absent everywhere, which makes it nice. There's no friction to account for here. Part A wants us to find the acceleration of block A, and block A is the one on the incline. And then it says B, if the system is released from rest, find the speed of block B after 4 seconds. All right, so let's crack this out. Here you have two blocks, right? You have a free suspended pulley here. You have a fixed pulley. Block B is attached physically to the free suspended pulley right here in the center. So if you have any experience with this, you know that these two blocks do not accelerate at the same rate. Okay, so keep that in mind. They do not accelerate at the same rate, just based on experience. And if you have made observations with the free pulley system, block A here will accelerate twice as fast. If you actually set this up, block A will cover twice the distance of block B. So let's say, for example, if block B falls down 1 meter, and block A will actually go up the ramp 2 meters. So we say that block A accelerates twice as fast because it covers twice the distance in the same amount of time. Okay. All right. So keep that in mind. So you keep up here. All right. I'm gonna go ahead and draw my free body diagram and accept the physics and find A and B. Here, block B is resting on the ramp, so we treat the surface of the ramp to be our x-axis, or we treat the whole entire system's line of motion to be our x-axis, which curves down. So here, the ramp is going to be our x-axis, perpendicular to that, which is my y-axis. Okay, so keep in mind, because the whole entire system is tilted, make sure you don't draw your y-axis just pointing straight at the page. It has to be diagonal, aka 90 degrees to the x-axis. I'm going to draw my f of g for block A out. My f of g is just down the page, so that's f of g A for block A there. Because f of g A now exists between my x and y coordinate, it has to have a y component and an x component. So here's f of g y, here's f of g x, and f of g A y is simply mag cosine theta. F of g by definition is mass times gravity. It's cosine because this leg is the adjacent where my cursor is going back and forth. I didn't put 30 degrees in there. If you've done any sort of incline problem, you know that this angle here is the same as the angle of the incline. Okay, hopefully by the time you got to this type of problem that you've done some sort of incline problem, so that should be hopefully obvious by now. So the angle that touches the f of ga and f of gay is the same as the angle of the incline, which is 30. Well, that's cosine because it is the adjacent. Therefore, f of gx, that's coming up here, this is your opposite leg. So this component here, f of gx, f of gax is going to be pointing down the ramp, and that's going to be mag. It's signed because it is the opposite leg of that angle. Okay, and then I'm going to draw f of n. The block A is resting on a surface, so there has to be a contact force that exists between the block and the ramp itself. Well, in this case, the ramp is going to push upward on the block, creating a contact force we call normal force, and that is going to be up along the y-axis. And Fn is always perpendicular to the surface. So in this case, perpendicular would suggest that it lies on the y-axis. All right. Notice here in the y-axis, though, there are only two arrows. Fn is pointing upward, and then f of gay is pointing down along the y-axis. These two arrows have to equal in magnitude because block A is only accelerating up the ramp or down the ramp. It does not leave the ramp. Okay. So over here, I'm going to draw f of g for block B. I drew f of g b, the vector, longer than f of g over here because I noticed when I read the problem, it says that the block B has a mass of 4 kilogram, while block A only has 2 kilogram. So 4 is more massive, so therefore I just drew the weight of block B a little bigger, okay, for technicality if you want to get all technical. All right. So keep that in mind. Here, block B is 4 kilogram, block A is only 2 kilograms, so I know the system is going to be accelerating to the right of the diagram. Okay. Here, I'm going to find my tension as well. Well, the force that's causing block A to move up the ramp is due to the string, and this string is going to be called T. And if this is T, if I were to draw the free body diagram out for this massless pulley, this is also a T. Okay. And then, well, this string is wrapped around this massless free suspended pulley, so there has to be another tension on the other side. Why? Because this string is hooked up to this particular fixed pivot. Okay, and then I'm going to label that as T as well. And then, last but not least, for this second string that's hooked up to the free suspended pulley to the hanging block B itself, there's going to be 2T. is 2t because this pulley here is assumed to be massless. Okay, so keep these conditions in mind as you practice. Most of these problems assume pulleys to be massless. If it does not, then you cannot make this assumption. All right. Here, this statement is true because this mass here is assumed to be massless. All right. So here we have t pointing down. We have t pointing down. So therefore, we need two t's pointing up. Well, if my cursor is tracing the string all the way around this pulley, okay, that pulley there is wrapped around the same string. So if this is 2t over here, there has to be 2t as well, because block B is going to go downward. The fact that there's a system hookup against it or with it that slows it down suggests that there is a opposing force, and this is going to be 2t as well. Okay. All right. So now that we have all that label, let's go ahead and set up the physics to find part A and B. Here, I'm just going to set up my block A and block B. And then I'm just going to make the statement. Block A is twice as fast as block B in terms of acceleration. So like I said earlier, block A will accelerate twice as fast as block B. So here I said block A is twice as fast as block B. Or if you like it, you can use the other perspective. You can say block B accelerates at half the rate of block A. Pick one, stick with it. I like the left one because I like the coefficient of 2. If you love fractions, by all means, use the one on the right. Okay. So here I'm just going to set up Newton's second law for block A. Net force equal to ma. And then, well, if you were to look at block A, which is on the incline, well, what's causing it to go up? This t, where my cursor is going back and forth. Well, there is an f of gx opposing it. Okay. So here you want to just use forces that are parallel to the surface of the ramp because the block is moving up the ramp. So t is parallel to it. F of gax is parallel to it. It's acting against it though, so I subtract. So t is pulling up. F of gax is against it. So I'm just going to subtract. Here I'm just going to break up. F gax is simply mag sine theta, which I already stated over here down my cursor circling. Okay. Well, here I need to find the acceleration AA, right? Because part A ultimately asks for the acceleration of block A. So I need to keep AA in my function. Well, I can just go ahead and introduce stuff now. Whatever it is that I know, MA is 2 because it's given. G is 9.8 because the negative sign is already accounted for. So here it's just positive 9.8 in the parentheses. Sine of 30 because the angle of the ramp is given. And then the mass of A on this side is also given, right? Excuse me. So if you simplify all this, 2 times 9.8 times sine of 30, that would just give you 9.8 because sine of 30 is a half on your calculator. And then a half cancels out with the 2, so it leaves you with just 9.8. So here I'm just going to clean up a little bit. T minus 9.8, which is equal to 2AA. All right. Well, here I have two unknowns, right? So once you have two unknowns, it should trigger the fact that you need to set up the physics for block B. I need to find AA. I don't know what T is, so I need to figure out some way to get rid of T. So I'm going to set up the physics for block B. However, if you look at block B, f of GB is greater than the 2t, so f of GB is going to be going down. The line of motion is taken to be positive. So therefore, we say f of GB, which is what's causing block B to accelerate downward, minus what's opposing, which is 2t. That equals the block B and the acceleration of block B. Okay. Here, I'm just going to break up f of GB into mass B times G minus 2t. And then we can just plug in values. Block B is given as 4 kilograms. G here is 9.8 because we take, once again, the line of motion to be positive. So therefore, this is just 9.8. Okay. Block B is given as 4. I don't know what T is, so I kept that unknown. But you notice here, similarly, you can clean up a little bit, right? 4 times 9.8 is 39.2. But here you notice you have 2T. You don't know what T is, right? And here's 4AB. Well, I know that both sides share a common variable, which is t, right? So what you can do is you can solve for t here on the left side and plug it into the right side, or right side and plug it into the left side. But as you do that, keep in mind what it is that you're trying to find. Ultimately, I am trying to find AA. So here, I want to substitute t into where I highlighted green there. So I'm going to move it, okay? So this is just a quick substitution. So 39.2, I carry down. I left out the units here because I'm running out of space. The 2 in the front, I carry down. Make sure you use parentheses when you substitute. So wherever t is, I put 2AA plus 9.8. So it's all in parentheses here. And here, like once again, I just left out the units, 4 times AB. But you notice here, though, you have AA and you have AB. Well, I know what AB is, right? At this point, you need to focus on what it is that you're asked to find. I'm trying to keep AA. I don't need AB. So what I can do is I can get rid of AB. Well, earlier, we made the statement, okay, for these types of problems, the acceleration ratios are going 2 to 1. You just have to identify which is faster. I said that block A is going to be faster. It's going to be twice as fast as block B. So therefore, if you were to solve for AB, you would just divide both sides by 2, which gives us this fraction right here. So we can say that AB, the hanging block for this particular problem, accelerates at half the rate of block A. So I can get rid of that and I can substitute it for AB. So instead of AB, I can say AB is AA over 2. So that's where the substitution comes in. Everything on the left side I kept the same, right? So here we just did 2 quick substitution. We got rid of T, we got rid of AB, and now the only thing left in the statement is AA, right? And which is ultimately what we're trying to get at. So here I'm just going to distribute the 2 to the whole thing, the whole parenthesis. So 2 times 2 is 4, and then 2 times 9.8 is 19.6, and it's negative because the negative is in the front here. So 39.2 carry down. Negative 2 times 2 is negative 4. Negative 2 times positive 9.8 is negative 19.6, and then 4 over 2 is just 2. And then here we're just going to combine like terms and clean up a little bit. I'm going to move this negative 4a to the right side so that I can combine like terms, and then I'm going to leave the coefficients here without the a alone. So it'd be 39.2 minus 19.6, which is equal to 2a plus 4a. Well, 2a plus 4a is just 6a, and then 39.2 minus 19.6 is just 19.6. So to solve for a, you would divide both sides by 6, and therefore the acceleration comes out to be about 3.27 meters per second square. Okay, so that is your acceleration. Now, part B, though, asks you to find the speed of block B after 4 seconds. So I'm just going to do it. Well, to find the speed of block B, since you're given time, I'm going to use this function. Final velocity is equal to a times t plus the initial velocity. But you notice here I'm using subscript b because part B asks us for the speed of block B. Well, I know the system starts at rest, so I'm just going to cross VI out. Here, I know what AB is. I know what T is. Well, earlier, we said that AB, right, is just half of whatever AA is. So I'm just going to plug it in. Well, AB is AA divided by 2 times T. Well, I know what T is. T is 4 seconds. I know what AA is. AA I just found, which is 3.27. So really, I'm just using the information that I just calculated. So here, 3.27 divided by 2 times 4, and that will give you an answer of about 6.54 meters per second. And that is the answer to part B. All right, other than that, I hope that helps. Stay nerdy, don't be whack.